All right, welcome back. Hope your day was a profitable one for you. Not necessarily financially, but there are many ways, of course, which we can term and measure profit in this experience called life. Over the years, and this June it'll be 15 years we've been doing this program, I've spent countless hours talking about subjects like intuition, divination, dowsing, precognition, remote viewing, all manner of discussions on these things, which can generally be traced back to some degree to non-local consciousness. We've talked, of course, with everyone from Brad Steiger to scientist Dean Radin to a literal who's who of the CIA's formerly top-secret military remote viewing program called Stargate. Tonight we're going to take a new and different look at the potential to use non-local consciousness with the Internet. This is an absolutely extraordinary topic, and the two guests we have lined up for you are equally such, and I'm very pleased to have them on, and this is going to be a lot of fun, and it will be, I guarantee you, something you'll remember for a long time. And you can participate in this to a degree. We're going to tell you how to do that as well. The website to go look at is called halfpasthuman.com. I love the title, halfpasthuman.com. And my guests are George Ure, that's U-R-E, and Clif High, that's H-I-G-H. Let's say hello to George first. Hi, George, are you there?
Yes, sir. How are you this evening, Jeff?
Doing well, thank you, sir. And Clif, how are you?
Doing just fine.
And remember, it does no good to complain. So thank you both for being in the affirmative as we begin. I mean, how many times have you met someone who said, how are you doing today? Really lousy. And most people reflexively say, just fine. Or people say, have a nice day. How many people have said to you, well, thanks, but I have other plans? I mean, it gets silly out there. But this idea of non-local consciousness is not silly, and it's something that is more than intriguing. Now, let's start with Clif, if we can. And for those of you on the Internet, go to halfpasthuman.com and tell us just give me a general overview, Clif, if you would, of what this is about, and then we'll get the same from George, and then we're going to move into the design patterns discussion, if we can. Clif?
Sure.
How'd you stumble upon this whole concept?
I was actually working for an unnamed large software firm, and they had an interesting
How large, Clif?
Oh, very large.
That's what I figured. Real large. Okay.
Real large, yeah. So big that you got to go 70 miles north of where I am to get
I understand.
And look from a vista to see them.
It's kind of
exactly.
Like you kind of have to walk through a gate to get there.
There you go. And these people had a really interesting software program that did the aggregation of vast quantities of data. Problem was, it worked, but it was what was called an operational failure, because basically they had so much data that the machines at the time, and this was a good decade plus back, were not capable of delivering the results of a query in human time. It was actually the engineers working on the project before I got there had labeled the response as a nano year. It was something less than a year before it would come back to you. You could type up the query and it responded just perfectly, but it would take perhaps 3 to 4 days sometimes before it would finally start spitting data out.
I see.
Obviously not a situation that you needed in a just-in-real-time enterprise.
Now, when you're talking about a query, what kind of inquiry are you making? What are you looking for? Just
In this particular case, these guys were storing vast quantities of information about the various types of IT equipment and other hardware that were owned by large corporations like Exxon, where you have hundreds of thousands of employees and each desk might have 1,000 items that's been assigned by the company. Make sense?
Okay. Yeah.
So they'd ask, what does so-and-so have, and how many of these do we have in the company that we can upgrade? And there were all kinds of tax relationships and other information attached to all these various different items. So you could get the information back, but it was huge. It was in a SQL Server, which is a standard or a structured query language. That's what the SQL stands for. SQL Server database running on some very powerful equipment. But even so, they were having nearly 1,000 permanent tables, and were creating 200 and 300 temporary tables at a time inside the database. And the database was just groaning under the response. So I came on in as a consultant because one of the things I do is I'm able to pick out what are known as the design pattern within a problem, the algorithm that seems to work in a fractal nature at very low levels in individual code snippets that you might find in C or C++, but all the way out if you looked at the algorithm correctly. And so what I discovered with these fellows was it wasn't that they were storing the information badly, but it was that they were storing the information at all. Because when I actually examined the database with some of my tools, I found out that they only had 23,000 words in there. And it was words like 386, Pentium, this kind of thing. But they had repetitions of it ad nauseum. So really, instead of what was happening was they were re-indexing the same words millions and millions and millions of times, and they didn't really need to. So what I did was to take their structure of 1,000 tables and flip it so we had 7 tables. They were very large tables, and they were very deep, but they were very well indexed and very fast.
Now, Cliff, excuse me, for our listeners, what was the point of indexing these words to begin with again?
For rapid recovery. So you could ask a query, how many 386 Pentium machines do we have that were purchased in 1986 with this particular format?
And you had a database of X number of words to mine on the Internet.
Hundreds of millions of them, correct.
So you would somehow reach out and scan the Internet for these words.
Oh, no, this is, I'm sorry. We were talking about how I first stumbled into this, and that was when I was working for these consultants. This was an in-house database then. But I took the same tact when I stumbled onto the idea that language is key, data is not particularly interesting. When we get back to the idea
go ahead. Why don't we make that underscored? Just remember out there, language is key. The data is secondary. This is an issue of language. All right, so this is where we're going.
Because I discovered, as I said, that here was this organization that had hundreds of millions of rows of data, but mostly it was about 23,000 words. The same words over and over and over again. So I started thinking about, well, why bother storing that word more than once? Let's just store it and make the appropriate tick marks next to it to tell us where it's being used.
Okay. Very good.
Boom, all of a sudden we started getting queries response in about 3 minutes.
They
loved it.
Instead of days.
Correct. It still took 4 days to spit out the totality of what you'd asked because we were dealing with hundreds of millions of rows, but it started right away and they were happy with that. So
what you did, you cut to the chase, as they say.
Exactly.
Okay.
But there was a side effect to it, of course. There's always a side effect for anything you do. In doing this and swapping the thousands of tables down to 7 tables, it translated the complexity of the structure of the request from the structure of the tables and having to know the tables to the structure of the query language. So as an instance, they used to be able to actually type in SQLese, they would say, select star from here where this condition equaled true. Now they could no longer do that because the data was not stored in basically a little dumb table that said Pentium over and over and over again. And they had to reconcile it back to a lexicon that I'd created of those original 23,000 words. And it worked, but it meant they really had to educate their SQL writers because they were now writing scripts that were themselves several hundred words long in order to get the same query out.
Got it. All right. Let's switch over to George here. He has something to add, I can tell. Go ahead.
Well, yeah, the real mind twister for me when I became involved peripherally on the project was getting through my head that you could take a very long word like misappropriation, and you could represent misappropriation with something very simple like the letter B or a hex number like 1C. And so all of a sudden misappropriation, which is a really long word to spell, could be represented by something else, and in doing so, you basically are flipping the language into a whole different way of looking at language. Does it make sense?
That's just so you gave it a code name.
Exactly.
All right.
But also, there's a little bit more to it than that. If you represent it as a hex integer, you're bringing it closer to the machine language.
Understand.
The machine works in numbers a lot better than it does.
Machine liked that a lot better. Okay, I got
correct.
it.
Correct. And basically all the letters on the Internet and all pictures are represented down in several different layers of numbers. And the closer you get to the native language of the machine, the faster it goes.
Ah, okay. Very good.
This is important to other companies like telephone companies, this kind of thing, where they have to process millions and hundreds of millions of records in a short period of time.
When did you two run into each other, George?
It was, about May or so of 2001. I had been living on my sailboat with my wife